Nature's smart ideas. For eons, nature has been perfecting solutions to a myriad of challenges. From the smallest microorganism to the largest whale, every living thing has evolved ingenious strategies for survival. Have you ever watched a bird fly, effortlessly gliding through the air? Or marveled at a spider's web, a delicate yet incredibly strong structure capable of capturing prey many times its own weight? If so, you're already thinking like a biomimicry pioneer. You're recognizing the brilliance inherent in the natural world. Biomimicry means imitating life, drawing inspiration from the natural world around us. It's about looking at nature's designs and processes to solve human problems, finding sustainable and efficient solutions that have already been proven effective over millennia. It's about learning from nature, not just taking from it. It's a shift in perspective, from viewing nature as a resource to viewing it as a mentor. Nature's solutions have been tested for billions of years, refined through countless iterations of trial and error. Before designing something new, we ask, how does nature solve this? What strategies has the natural world already developed to address similar challenges? For example, to create strong, lightweight materials, we study bone, examining its intricate internal structure, or seashells, marveling at their ability to withstand immense pressure. To collect water in dry places, we look at desert beetles, observing how their textured backs efficiently capture moisture from the air. Biomimicry isn't just copying, it's understanding the principles behind nature's success. It's about deciphering the underlying mechanisms that allow natural systems to thrive. We study how birds' wings work to design better aircraft, improving aerodynamics and fuel efficiency, or how forests clean air to inspire city planning, creating urban environments that are healthier and more sustainable. Biomimicry bridges biology and engineering, helping us innovate sustainably and efficiently, creating technologies that are both functional and environmentally responsible. It invites us to see the world as a library of ideas, a vast repository of knowledge waiting to be discovered and applied. Ultimately, biomimicry is about fostering a deeper connection with the natural world, encouraging us to live more in tune with our planet and its delicate ecosystems. Why turn to nature for answers? Nature has a 3.8 billion year head start on research and development. Every plant, animal, and ecosystem is a survivor. Nature's solutions are time-tested. In nature, there's no waste. Everything is reused and recycled. By studying these closed-loop systems, we can design cleaner, more regenerative industries. Nature runs on sunlight, uses only what it needs, and fits form to function perfectly. Its solutions are often more creative than anything we could invent. From muscle-inspired glues to termite-inspired cooling systems, nature's creativity is boundless. Studying nature reminds us we're part of it, fostering respect and connection. Biomimicry is more than problem-solving. It's a mindset for living in harmony with our planet. Biomimicry isn't new. It's a practice as old as humanity itself. For millennia, humans have looked to the natural world for inspiration and solutions to the challenges they faced. Humans have always learned from nature, observing the intricate details of the world around them. From the behavior of animals to the properties of plants, early civilizations gleaned invaluable knowledge that shaped their survival and development. Early humans observed animals to find food, studying their hunting techniques, migration patterns, and the subtle signs that indicated the presence of prey. This knowledge was crucial for sustenance and survival in a challenging environment. They also used plant fibers for tools and shelter, understanding the strength and flexibility of different materials to create essential items for daily life. From woven baskets to sturdy dwellings, nature provided the building blocks for civilization. Even the first fishhooks were inspired by natural shapes, mimicking the curves of branches or the forms of insects to lure fish from the water. These early tools often mirrored nature's own designs, like claws and thorns, adapting natural forms for human purposes. The ingenuity of early humans lay in their ability to recognize and replicate these natural solutions. Centuries later, Leonardo da Vinci studied birds and bats, meticulously documenting their anatomy and flight patterns. He sought to unlock the secrets of avian flight to design flying machines, driven by a desire to emulate nature's mastery of the skies. Da Vinci's observations and sketches, though not immediately successful, were instrumental in laying the groundwork for aerodynamics and the future of aviation. Today, biomimicry is a sophisticated science, employing advanced tools and techniques to analyze and replicate nature's designs. But the core idea remains: learn from nature. By understanding the principles that govern the natural world, we can develop innovative solutions to a wide range of challenges. The Shinkansen bullet train in Japan, a marvel of modern engineering, was redesigned after engineers studied the kingfisher's beak, a bird perfectly adapted for diving into water with minimal splash. This biomimetic design significantly reduced noise and improved energy efficiency, solving long-standing problems with the train's performance. Similarly, Velcro was inspired by burrs sticking to fabric, a common annoyance that sparked a revolutionary idea. The tiny hooks on the burrs, designed to cling to animal fur, led to a global invention that transformed the way we fasten things together. From ancient tools to modern technology, the thread of biomimicry runs throughout human history. Nature has always been our guide, offering a wealth of knowledge and inspiration for innovation and progress. These stories show that observing and understanding nature leads to breakthroughs, unlocking solutions that might otherwise remain hidden. Whether it's flight, fast trains, or everyday fasteners, biomimicry offers a powerful approach to problem solving. Nature's blueprints are everywhere, waiting to be discovered and adapted for human benefit. Biomimicry connects our past and future innovations, reminding us that the natural world holds the key to sustainable and effective design. The more we look, the more we find, revealing the endless possibilities that nature offers. Nature's genius is timeless, a source of inspiration that will continue to drive innovation for generations to come. Nature is a master, a true virtuoso of aerodynamics and efficiency. It's a constant teacher, offering lessons in how to move through the world with the least amount of resistance and the greatest amount of power. The peregrine falcon, the fastest animal on Earth, inspired new aircraft and drone designs, pushing the boundaries of what's possible in flight. Its success lies in its streamlined shape and airflow management, a perfect example of natural engineering. The boxfish, despite its blocky look, which seems counterintuitive to speed, is surprisingly agile and remarkably stable. Its unique shape inspired a fuel-efficient Mercedes-Benz concept car, demonstrating that even the most unexpected forms can hold valuable secrets. Humpback whales' flipper bumps, or tubercles, those seemingly insignificant protrusions, reduce drag and significantly increase lift, allowing for incredible maneuverability in the water. This discovery is leading to better wind turbines, making them more efficient at capturing energy. And quieter fans, improving our everyday lives with biomimicry. Even insects like dragonflies, with their intricate wing structures, teach us invaluable lessons about flight. Their ability to hover and dart with precision is truly remarkable. The mechanics of their wings inspire nimble micro-drones, opening up new possibilities for exploration and surveillance. These tiny drones are particularly useful for search and rescue operations, navigating tight spaces and providing critical information. Nature's designs often defy expectations, challenging our assumptions and pushing us to think outside the box. They are showing us new ways to move efficiently, conserve energy, and adapt to challenging environments. By studying animals in their natural habitats, observing their behaviors and adaptations, we learn to build faster, more aerodynamic vehicles and aircraft. We also create more stable and more agile machines, capable of performing complex tasks with precision and grace. Tiny details, like the tubercles on a whale's flipper, which might seem insignificant at first glance, or the precise angle of a falcon's beak, perfectly designed for tearing through the air, can revolutionize technology, leading to breakthroughs we never thought possible. Nature's flyers, from the majestic breaching of whales, defying their massive size, to the delicate dance of insects, each one a master of its domain, show us how to move with grace and speed, inspiring us to create more elegant and efficient designs. The animal kingdom is a living laboratory of innovation, a treasure trove of ideas waiting to be discovered. Every shape and feature has a purpose, meticulously crafted by evolution over millions of years, waiting to inspire us and guide us towards a more sustainable and innovative future. Spider silk is one of nature's most extraordinary materials, 5 times stronger than steel, yet light and flexible. Spiders use it for webs, protection, and catching prey. For humans, replicating spider silk could revolutionize medicine, textiles, and construction. Its strength comes from a unique protein structure, rigid crystals for strength, flexible regions for stretch. Scientists are decoding the spider's genetic recipe to produce silk sustainably, using organisms like yeast and bacteria. Synthetic spider silk could be used for dissolvable surgical thread, artificial ligaments, lightweight clothing, and even suspension bridge cables. The challenge is large-scale production, since farming spiders isn't practical. Genetic engineering is bringing us closer to mass-producing this miracle fiber. We haven't perfected the process yet, but progress is rapid. Spider silk shows how nature creates high-performance materials under life-friendly conditions. The quest for artificial silk highlights the value of learning from nature. Nature's materials inspire the next generation of sustainable technology. Imagine a phone screen, constantly prone to scratches and cracks. Or consider car paint that has the amazing ability to heal itself from minor damages. This is rapidly becoming a reality, and it's all deeply inspired by the wonders of nature. Living things have the natural ability to heal wounds. And now, scientists are diligently mimicking this process with self-repairing materials. Tiny capsules embedded within these materials release healing agents when cracks begin to form, quickly hardening to effectively repair the damage. It's a process that mirrors the way blood clots to heal a wound. This groundbreaking technology has the potential to significantly extend product lifespans and dramatically reduce waste. The applications are vast, ranging from self-healing airplane wings to concrete that has the ability to seal its own cracks. Even everyday items like pipes and boat coatings can greatly benefit from this technology. Nature also inspires materials that can adapt to their environment and grow stronger over time, much like bone does. By carefully learning from nature's inherent resilience, we can design products that are not only long-lasting, but also highly adaptable. Biomimicry is actively shaping our world, right now, in very tangible ways. The Eastgate Center in Zimbabwe, for example, stays remarkably cool without the need for air conditioning, inspired directly by termite mounds' ingenious natural ventilation systems. Robots mimic animal movement. Snake-like robots are used for search and rescue missions, and gecko-inspired robots are designed for climbing various surfaces. Solar panels are being redesigned to mimic the structure of leaves, maximizing sunlight capture and overall energy efficiency. Wind turbine blades are now taking cues from the unique shape of whale flippers, and water-repellent coatings effectively mimic the properties of lotus leaves. Medical adhesives are being developed, inspired by the incredible sticking power of mussels. These innovations clearly show how nature's fundamental principles can lead to smarter and far more sustainable technology solutions. Biomimicry ultimately helps us create solutions that work harmoniously with, not against, the environment. The future of design is undoubtedly rooted in nature's profound wisdom. As we unlock nature's secrets, we must act responsibly. Biomimicry isn't just about borrowing ideas, it's about respecting and protecting the biodiversity that inspires us. Every lost species is a lost library of solutions. Protecting habitats is essential for future innovation and survival. True biomimicry means designing products that are non-toxic, efficient, and recyclable, just like nature. We must ask, do our innovations help the planet, or just serve short-term needs? Biomimicry teaches us we're part of nature, not separate from it. It encourages humility, wonder, and stewardship. Observe, ask questions, and support biomimetic research. Cultivate respect for nature's wisdom. By embracing biomimicry, we solve challenges and learn to live sustainably. Nature's genius is the key to our future.